Good afternoon and welcome. Our talk today is Come Join the Continuous Automated Firmware Security Analysis in Mandalay Bay Room JKL with Collin Mulliner. Before we begin, I have a few very brief notes. Stop by the business hall located in Mandalay Bay, Oceanside and Shoreline ballrooms on level 2 during the day and for the welcome reception tonight at 5:30 p.m. The Blackhead Arsenal is in the business hall on level 2. Join us for the Pony Awards in Lagoon JKL at 6:30 p.m. It's in this room. And thank you for putting your phones on vibrate. It makes it easier for the rest of us to ignore the ringing. Collin, it's all yours.
Thank you. Yeah, hello everybody. So today I'm going to talk to you a little bit about continuous firmware security. Yeah, my background is basic security, but also I've spent a lot of years actually building devices, like embedded devices. So yeah, this basically combines like what I do for like many years. So in building devices is really hard. Like if you ever worked in a company where you actually build like an embedded device or consumer electronics, it's a lot of work. And building a secure device is like even more work. And when I talk about devices, it's really like industrial, a little bit of IoT, and say customized Android devices, or general consumer electronics. And because I work for a car company, for me, the car is lots of different small computers, all connected together on their on wheels. That's how I think about it. And your product is secure if all the little components are secure. So when we talk about devices and firmware, in this talk I really focus on devices that have a full operating system. So you have a kernel, you have a user space, you have actual file systems, and your firmware consists of like, yeah, that combination, kernel, file systems. I don't really, in this talk or work, we don't really look at, say, like those like smaller devices where you just basically have one blob that's just starts a number of tasks and have a little bit data. Everything is mixed together. You don't have really a differentiation. So basically, this covers mostly like devices that like run some kind of Linux, for example, like any kind of Android device, and like similar devices. Say like a QNX-based device would basically be handled exactly the same way. And these days you just have firmware everywhere, like every little thing has firmware in it. And firmware is really your product. And your product is what's in your firmware. So if you think about firmware security, you really look at multiple things that have to be there and play together in order to have secure firmware. So we can start saying like secure boot, like so you want to have something that validates your kernel and file systems before you, like during boot. You want to have the production version of your configuration files. You want to have production binaries, so you want to have no debug or development or test binaries or your normal binaries without those features. And then you want to have all of your production access controls, so file system permissions, labels. You want to have the right cryptographic material. So you want to have your production version and not something your developers use. And of course you want your hardened code. So you want production builds of every binary. You want hardened options, no symbols, and so on. So if like all of these things play together, then your firmware is getting secure. And yeah, for this talk, I just like Googled a little bit around for CVEs that specifically mention firmware as like firmware bugs. And if you look at this, you can see like, oh, there was this device. The makers of the device forgot like their private RSA keys in their file system when they shipped the firmware. Or like another example, like the etc shadow file was like world readable. Or this last example where it says like, oh, we found this like undocumented SSH server running on this device we bought. And then you can see like later, oh, they actually removed it. So it seems, yeah. So there's like very simple things where you maybe don't think about it. It's not like the exploit like in your web in the web browser, the web server that runs on your device. It's like all the little other things that can hurt you way more. So how do you get like those kind of bugs? In general, like people think, oh, when you develop develop a product, you just have your developers, you have your CIs, your testing, everything like runs smooth. You go from prototype, development, testing, you do a little bit of QA, you have your pen test, and then you have your product, you just sign it and ship it. But of course, it's not like that. Anybody who ever worked in software or like device manufacturing, you know, like you have a new feature, and then you have to disable something to debug something. You add another feature. It's like, oh, we need to open this network port because you have a new thing. And it's like, oh, some developers really need to like debug on device, so you add like an SSH server. And then QA wants some feature, and then you remove some functionality. So like there's really constant change, and a lot of, just like everything changes all the time until you have your final thing. And just being able to secure a product while all of this happens is just like a lot of work. And basically one thing you really want to prevent is just like this ripple effect. If you like ship something that's bad, so maybe you ship something where you have like none or really like partial working security controls. Maybe like you ship a defective product because maybe your security is so strong and like your certain things don't work because you didn't test that like in any circumstance, like a specific thing can like read a file or access like a specific network port. Or maybe you accidentally cripple your update because maybe you shipped like wrong public keys. So basically, you really want to prevent this because it's, yeah, it can create like a really long-term negative effect like on your product and company. And yeah, it's easy to like lose your reputation, and like maybe you have to like recall products, or maybe not recall, maybe you just have to like, yeah, maybe you have to like completely trash them. And like stuff like this like happens, like you can read about this in the media. So in order, what do you really need to do? So of course you have to bring in automation, because if all of the stuff changes all the time, so you want to have something that you can use to automatically look at your security. And I really like to talk about security QA, because security is one part, but you also need to like have assure that the thing that your security is like has good quality. Like security and quality really go hand in hand. So we looked at this and was like, yeah, okay, so we need a tool that we can use to like automatically perform security checks. And then with this tool, you need to deploy it in strategic locations in your development flow. And I'm going to go through the tool, how we deploy it, and like what are the benefits. And of course, you need to take the results and do something with them. Just like knowing that like something is bad doesn't really help you that much. You really want to feedback that information to whoever is like building the device. So we built this tool that we call Firmware Analyzer, and it's really like a tool for security QA for firmware. And the really basic functionality is you have some rules that your experts create, and those rules are enforced, and you basically get a report. The rules are really enforced on individual file system images of a firmware. I will go into like more detail how we look at firmware and what the different components are. And you really want to like enforce things like type ownership on files, like, and you also want to look at file content. So is this the right file? Does this file contain so-and-so? Does this file not contain something? Or you want to like run maybe an external program to analyze and like a specific kind of file to get more information. And really the big use cases are you want to run in CI so that on every build you look at the firmware and can like flag problems. So developers can immediately, like they don't get their PR merged if you find things. So that's really good. And then of course, like in all modern devices, you basically have signed updates, secure boot. So you really want to like prevent signing like bad firmware. So basically you can put a tool like this in front of your production signing system, and you only sign firmware that like passes. And of course, things like acceptance testing. You buy products from third parties. You want to look at the firmware, and you can also do that. Yeah, basically, we open source this. Since today. I will have another link at the end of the slides, but yeah, this is like not a product, it's a completely open source tool. We take PRs, and so on. So the main goal really for this is we want to prevent high impact changes from going into production. Like no debugging features, no reconfiguration, and really prevent this ripple effect. And most likely you spend a lot of effort building security features into your product, and it would be like really sad if you like ship something and like due to some mistake, maybe like security features get disabled, or maybe security features disables part of your product. And it's really to like create confidence in the security of your product, because you have a lot of things to do, and that should help you. Additional goals of this is we not only want to like prevent and like shipping something bad, but you also want to have visibility. You always want to see what's going on. And when you have like just a piece of firmware, it's hard. You want to like, you maybe even don't want to know into versioning information, security parameters. Of course, the tool is built for automation. You don't want to have like people sitting there and like typing something and like manually analyzing and like, so you want to like really have the system that you can integrate into your development pipeline. And for this reason, for example, we produce machine readable output we can just like use in post process. And also collaboration. You want to like be able to share like your experience and knowledge, maybe with other product teams in your company, but like also externally. So it's also built for that you can very easily share like checking rules and so on. So the one big thing, like in the scope of this like tool and like the system, we really don't care about software vulnerabilities. Like, so this tool is really not to find like bugs in your binaries or source code, or we don't like scan for CVEs in your software stack. There are so many different tools and products you can use, and you probably like already have something to like do source code analysis or binary analysis. If you really want to use both together, the firmware analyzer has like a scripting engine, and you can very easily plug something in and you can combine. But this is not yet another like we find vulnerabilities or bugs in source code or binaries. So it has nothing to do with that. And if you just like look at very simple invocation, so now I'm going to just like walk you through like what's like a very standard workflow and show you all of the options, and then later at the end we're going to show how we actually deploy this and use this in reality. So basically, we start. You basically have a configuration file, and we'll go into that in detail. And you have your file system image, and you run it, and then like one of your checks will flag something, and you know, okay, this one of your rules triggered, and that's the basic functionality. So when we talk about firmware, I really talk about file system images, because basically what is firmware? We have a kernel, file system image, all of them are bundled together in like something like a zip file or a CPIO archive. And our firmware analyzer really targets factory or full firmware updates. We're not really looking into like delta updates or like during the build stage, really what comes out at the end. Because depending on how you build, you can really only tell at the very end, like this is like the final stage that you're going to ship. Because just in the way like stuff gets bundled and created during build time, and like all of the build systems are different. And the nice side effect of this is that at the end you have automatic support for commercial off-the-shelf devices. So if you just buy some device, get a firmware update, you could look at it. So why do we actually look at file system images versus just like some files? Because of course we're like not only interested in the content of the actual file, but also in all the metadata, file owners, types, permission, attributes, something like SLinux labels, directory structures. And the nice thing what we can do, we can actually compare entire file system images against each other. So if you have two different versions of the same image, you can just say, hey, what changed between them? And that's like even a completely automatic feature where you don't have to do anything, which you can all not do if you just like look at single files that you maybe like extracted from like a binary block file system. Yeah, and so firmware analyzer basically you need a little bit of infrastructure. So you have the actual executable, and then you have something that we could just call like check.py, which is like a simple wrapper which like implements like firmware unpacking, because really depending on your device, like all firmware updates are like, they're just different. If you look at like an Android update versus, I don't know, say like from a TV, from a smart TV, this firmware just looks completely different. So the unpacking part, that is not something like we do, but that's like, if you build a device, you know how your firmware looks like. So, and then you have configuration files. It's basically just like all the different checks. And then you have like this file tree files. It's basically a dump of the entire file system, where you just have meta information about every file. And those together basically build your infrastructure. So yeah. And the configuration files and file tree, that's basically the variables that like change, you want to update them. And the actual workflow looks like this. You take your firmware, you unpack it, and you get all of the different file system images, and then they get analyzed individually. You get your nice report at the end, and then you can do some post-processing, and then maybe you combine them at the end. So let's look a little bit at how this tool actually works. So basically, yeah, as I said, it works in file system images, but the tool is built to like analyze them without mounting them. You want to run the tool in CI and maybe in places where you don't want to mount anything or like have root access. Currently, we support a bunch of different file systems, like all the X file system, VFAT, SquashFS, and so on, and also like a local directory. So like, if you just can unpack something and get a bunch of files, you can also treat that directory as like a file system. Yeah, the output is JSON. Is like really easy for post-processing and automation. A lot of tooling, especially if you look at like cloud-based log services. They all have really nice JSON support, so you can like do like also awesome stuff at the end with that. Once you reach it, you reach like your cloud service, which I'm also going to talk about. On the basic output is you have offenders that are basically violations of configured rules. Basically, if as soon as you have like one offending rule, the analysis like fails, and it's like, yeah, this is not what we want. And then you have informational output, which is basically non-fatal checks. That's basically for visibility. And you can also do like rule testing with that. And one of my favorite features, actually like this data feature, basically you can extract data from different files of the file system, and they end up in the report. And you can like get really, really awesome visibility into your firmware. And you can do like very interesting post-processing with it. This is just like a very simple example. So if you go from top to bottom really quick, you see like, yeah, this was like an X file system. We have the full name of the image, we have the digest, and then you see like data, for example, there's like build information, versioning information, and some informational structures, and we have like a few failed checks. So if you go and like start building a configuration, that would be like just in the global config is basically you have like a file system type, some options for that, and you can select basically your driver. And all of the file system drivers are just like implemented using like common like open source tools. So we don't actually have to like implement like file system parsers. Internally, every check is run against like this abstract file. So basically we have like a virtual file system inside this tool. So checks don't really need to know anything about the file system type. And it's also really extremely easy to add like new checks to this engine because you don't have to deal with anything but an abstract file. Yeah, and so we normally would start with like this like very global checks. It's like very easy to understand. So say flag any SUID file, flag any rolled writable file. Then you can say like files on this image are should only be owned by this following user and GID, or a set. And you so I guess have like a list of bad files. So like, hey, in this production firmware, you probably don't want to include like things like TCP dump or whatever like fits into like whatever you think doesn't need to be there. So it's like a very easy to understand initial configuration. And then we can model things like direct like the metadata of every file. For every file that you want to check, you don't have to do that for every file, of course. You can just like say, hey, this file should be owned by this user. It should not be empty. it should be like this mode. So you can model like key security relevant files. And like just this example, which I put in because of the slide that I showed you in the beginning, where like etc shadow was world readable, and that's something like very easy. Like something like that can very easily slip, like somebody changed like permissions on your etc directory, and it's like something very easy to catch. File content is basically the main option to like analyze the content of your file. And we have like built many different modes, so you can like say apply this regex. If it matches or not matches, then you will flag that. Or you can say, hey, we want this very specific file to always be this have this very specific content. And you do that by just saying this file has this like SHA-256 digest. And like JSON becomes more popular, so we can actually also natively understand JSON files. So you can actually say, and in this specific file, there's a JSON structure that looks like this, and this specific value has to like correspond to like your configured value. And you can just like run an external script. So if you want to like have some very specific thing you want to do, you just configure and run a script, and whatever the script outputs is what's happened. So there's like a few examples. So the first, if you go from top to bottom, the first is just like, yeah, we want to make sure a specific file system is mounted but non-executable. Very easy check. So you just apply this like regular expression. If it matches, it's all good. If you go to the next one, it's like, hey, your over-the-air updates, your over-the-air certificates. So like your public keys for and certificates for like updates. This file should always be this with this specific digest, so like very specific version of a file. And then if you go to the next one, you see, oh, we want to make sure we don't ship unstripped binaries, so we can just like run the shell script. And as you can see, like file doesn't have to be a file. You can just like, hey, execute the script against every file in a directory. And you say like, yep, this file is not stripped. And then other things like, and just like, hey, we want to make sure you have a proper like DM verity key configured. Just a few examples of what you can do with this, and those kinds of rules are like extremely easy to like build and experiment with. Yeah, and then the data extraction that I talked about basically has almost the same functionality. You can like have a regular expression with a capture group, and you can say like extract me this part from this file. Again, natively read JSON, or you can again run a script and use the output. And then you can really say like, yeah, for example, get the version and put it into our data output as version. And then you can, in the end, when you can read the report, you actually see what are the outputs of your checks to like what does like the like say version number or build type tells you. And that's like really, really easy for visibility things. Yeah. So like every time this tool runs, we generate something that we call a file tree, which is basically just a gigantic list of all files with all permissions, owners, and this looks something like that. So like we'll generate gigantic files that has like every little detail about your file system. And the nice thing is when you run it, when you get a new firmware version or like new revision, you can just like compare those two files. And you say like, hey, there are some new files, or some files were deleted, or files changed permissions. So it's like a very easy way to just like keep track of changes over time. Yeah. As I said, yeah, you can also just like run scripts. So if you want to have a little bit more custom checks, the firmware analyzer will just like extract that file from a directory, and extract the file and dump it in a temp directory, and the script runs against that. So the script also doesn't have to know anything about the underlying file system. And then you can like build cool things like, yeah, detect like if files are stripped, or like if they're like dep or ASLR enabled. You can see like, yeah, does this maybe contain private keys? Or say you have an Android device and you can basically pull out every APK and just like run your custom checker against it. So there's a lot of different things what you can do with this. Yeah, so normally when when the tool runs and you have a check, and the check fails, then it produces like what we call an offender. Basically, you say this file should have this file permission. It doesn't. You say that's a bad thing. And there is this thing that we call informational. It's basically non-failing extracted information. And it's just like to like see what's there. And sometimes, so say you're already like in production and you want to like add more checks, and maybe you don't want to like immediately make it a failing check. So you can set basically every test. You can just say, yeah, just set it to informational only, and then like instead of failing, it will just like give you an informational entry. And it's like really nice to like test out new checks. Yeah, so now that we have like all of the different checks configured, the post-processing is basically where you say like, okay, we run it, we extract the firmware, we run the tool, we get reports for each different file system, and then we can maybe do some checks on top of like extract the data or combine just like the reports. And yeah, you can do stuff like compare like values across different file systems. You can do like maybe statistic analysis of like file types and so on. Like there's a lot of different things you can do here. Yeah. Okay, so I'm gonna walk through like an example, and I really just wanted to like find like a random user debug Android firmware. Like we don't use this device. I actually never saw this device. I was just like, hey, I want to have some Android firmware that is like not a production build, so we can go through and like show a bunch of interesting things. And this was really, it's a demo for the tool, not really, we didn't try to find bugs or anything. So in the beginning, your check tool basically has to like do the unpacking. And there's lots of different tools for Android where you can just like unpack and reconstruct those sparse images, so get just like standard file system images back. So you got like all of the different images, and if you know Android, you know like boot image is like not an actual like file system. It's just like it's a combination of the kernel and like a ramdas. So you also have to extract that and dump it in a directory. And then you have to go through basically and make a custom configuration for every file system. We're gonna like quickly walk through two of those. So basically say, okay, so this is Android, so we want to like definitely check for SLinux things. There are certain SUID binaries which we want to whitelist. We know common UIDs on Android. It's like 1000, 2000 and so on. We want to like have all those files. We don't want to have SU installed. Where we want to make sure the specific OTA certs are installed. And we want to extract a bunch of like information, say like Android properties. And that's another feature I'm gonna show you a little bit later. So basically you can write checks once and then just include them into like other configuration. Here, for like a boot image, since that's something that's actually not a file system, we just extracted a bunch of files of this like blob into a directory. So you say like, this is of type directory fs, so we'll just, firmware analyzer will just treat the root of that directory as like a file system root. Yeah, and then you have a bunch of checks again, and a bunch of data extracts. Yeah, so if you now look into like some specific Android configurations, it's basically what do you want in like a production build. On Android, a production build is called a user build, so you want to have your RO build type equals user, and you want to have like RO secure and RO debuggable set to production values. And you could write these these checks, and we actually that's part of the open source release. We just have like different checks for like different kinds of Android builds, which you can just like include then in a configuration file. And then we of course want to extract all the different properties, for example, the build type, build tags, build flavor, and something like the security patch level. And so then you just like run it. You have like this check script does like all of the legwork for you, like and extracts the file system images, reassembles all of the different parts, unpacks, boots, and then it just like runs firmware analyzer on all the individual parts and generates a final report. In this case, the check fails because this file is a user debug build, but we were like checking for user build. And so if you just go through the report, you can just like see like very easy in the top, it's just like the firmware, the file name of the firmware, and then you see this, all the different subcomponents like the boot image, the system image, the vendor image, and you see like every one of them contains offenders. So if you dig in a little bit closer and look at like the offenders just like for one device, you see like the build properties indicated this is not a user build. And the OTA certs is a different file than we actually wanted. And files like xbin su exist, which we do not like want, which we said like this is not a file that we want. And then the data, so we said like, hey, extract all of those interesting pieces of properties, and then you see like immediately anybody who ever like saw like looked into like Android firmware, you see everything you really need to know. You see the build fingerprint, the device name, the security patch level. So you can get a very easy understanding of what you're looking at. Yeah, on like test keys, and yeah, it's like it makes things very easy. So in this case, the result is this is a user debug build, so it failed the test because you configured like it for a user build. And with one look, it's like you see everything. So it's like really awesome visibility. You see like the fail checks, and you see all of the versioning, build flavors, and so on. So I think that's pretty awesome. Okay, now we have the tool. We know how it works. We know what we need to build for like infrastructure around it. But the tool itself, like if you don't really deploy it deployed like in your company, it's not really, yeah, like running it manually is like it's like not even, you don't even get halfway there. We really want to have it like in an automated way. So I'm going to talk about what can you do like in a development environment, production signing, and so on. So in development, really the goal is to prevent like development moving forward with like bad or incomplete information. Because developers really want to do the right thing, but they are not security experts. So you want this, if you run it every build, you can provide very easy feedback during development. And you just have it as part of your unit test. So like if your CI invokes like make test, you also run this at the end. And then it's like, you can make developers very easily aware, because it's like, yeah, you can't have like say SUID binaries in a specific like device. So some examples. So for example, like SLinux really breaks assumptions about file access. Missing on the a missing label or the wrong label is basically, yeah, this should read like, well, my file is world readable, but why can't I read it? Of course, because you have SLinux. So it's like one very easy check that you can do, and like stuff like that is like very easy, and just like to help you to like unblock development without like breaking security. Or file permission and ownership. It's like, yeah, your software just like wants to read a file, and so the software doesn't care that the file is like world writable, right? But the security person cares about it. So you can very easily just like configure the script and configure this check, and then CI is like, yeah, everything works fine, but you should change like the permissions on this file probably. And basically, yeah, that's just like a screenshot from, yeah. So basically, you build it, you put it into your CI, and then you just like see output like this. And you might want to disable like certain kind of checks. For example, you don't need to like calculate the digest of like every file system image in CI, because you not really want to ship it. So that doesn't really help you, but it would slow you down if you like have it on. Because you really just want to have like all of the checks, but yeah, nothing that you really need to record over time. Yeah, so production signing. So what happens when you sign a firmware with like your production keys? That basically means it will run on every device of that specific class you ever shipped. and you really don't want to like sign like something that is insecure. It might cause huge damage and use problems. Of course, like you can have things like rollback protection, so you can make a fixed version, and then from that point on, you can never go back. But everything really depends on like how your products work. But you really want to do like production signing after you have completed testing, development, and everything. It's basically the final stamp of approval before you ship. And yeah, what are things you might want to do? So you want to really make sure you have a production build. You want to have your right certificates. You want to have all of your like hardening features on. You don't want to have like development tools on it anymore. You want to have your production configuration files. So basically, what you can do on your production signing server, you have a pre-state, which basically is firmware analyzer. You submit your final firmware image to the signing server. The server like runs the checks, and if none of the checks fail, it goes on and like signs the firmware, and you get it back. If checks fail, then you say like, yeah, we can't sign this, and you get like, you can take the report and maybe send it back to the person who like tried to sign it. So it's like a very easy like pre-step to like prevent very simple mistakes that could have like a really bad impact. So that's like a really nice thing. You can also do acceptance testing. So say you buy devices from a third party, and then it's probably you do like some initial acceptance testing where you figure out how everything works. You find out what's a good state. You go forward and back with your supplier. And at some point you create like this configuration file where you can capture like a known good state. And every time you get like a revision, you just reanalyze that image to see if anything changed that you might want to know of. And of course, you should like extract as much data as possible, so you can like actually like have like a good record. So you can also automatically create like a record for like firmware. Every firmware you get, you can create this like big gigantic JSON blob, and you can just keep that for your record. And yeah, you can find changes before like they bite you. And something like that is very nice. Say you have the service, your supplier uploads the firmware, you get the report, it goes into your database, you get some email notification, and you maybe see like some new files or some changes, and you can very easily then circle back with that supplier and say, hey, we found you did this and this and this, was this intended? Please tell me more. And without like going through like doing any of this like manually, just like it just runs, and you get like all of this like really awesome information. And it also not only like gives you the insight, it's just like also so much faster than like doing this manually. And yeah, and don't think you have like only like one device. Say you have 10 devices, 20 that you maybe have to take care of. Like this is like a huge benefit. Basically, that's I already covered that. So you can like, it's really easy to go like to fastly iterate also with external people, and you get really good like visibility into like firmware revisions. And of course, you can also do like kind of vendor assessments. Say you buy some device off the shelf and you want to like do some testing. So this would be more like something that would help you like in some manual analysis. As like one of the many steps in like something like vendor assessment. And actually, you deployed your tool like in front of your production signing, and like you have this firmware securities analysis service, and if you just like take this like JSON output and just like pump it up to your like favorite like cloud-based log service or maybe hosted log service. You can do like really interesting like post-processing where you can automatically like have triggers on different like offenders or informational or data points, and have like automatic alerting, reporting, maybe create tickets. And and that's like really why we have like structured output, so you can very easily integrate this into other things. And this like really showed like a lot of great value. So say you have this tool, you want to use it. Basically, the main thing you have to do, you have to build an unpacking step and create some config files. So basically, in your check.py version, you have to like build a firmware unpacker and maybe add some post-processing and so on. And what you really want to do, you want to create like config files for all the different file system images. You have to select the appropriate file system type. Start with some like really easy like global check rules, and then like slowly add more specific rules and so on. And move as many checks into like checking libraries, so you can like very easily use the same check like for your production and for your like development like analysis step. Yeah. So yeah, in order to do this, you just like basically you can use this like include function, very simple. And the really nice part is like you can also share like rules with, you can just like open source like your checks and keep maybe somebody product specific rules to yourself. So it's really meant for like sharing. Yeah, in the future we want to like just support a little bit more file system types, some scripts like also like analyze kernel config. Some people might know checksec. It's like a really cool Linux tool to like check ELF binaries to see if they're like supportive of ASLR and DEP. And maybe like if you like build Android device, you want something like an APK checker. So it's like all things that would be nice to have. Yeah. In conclusion, you can say like we like really like really happy with this tool. Like we deployed it like in CI for like a major product or a major like project. We really gate production signing for multiple devices. But you always have to like understand this is just like one piece of the puzzle. This only having this is not solving your like issues. You still have to build your security controls. You still have to like audit code. You still have to do the other work. It just is just like helping you to automate certain aspects. And it really has shown value. We caught a bunch of like things that would have not been so nice. And but if you caught them, they never happened. That's why you have things like that. So it's really, if you go back to like this initial thing, like you're maybe a little bit unstructured like development process, or it's like not unstructured, it's just like not how you do it. Like things just like change over time, all the time, every day, and we still as a security team want to be on top of it and like make the most secure product possible. And with that, like we were like really, it's really much harder to miss like security relevant changes. Automation of like feedback during development like seems super awesome, and it's like and it like creates a little bit of confidence and of peace of mind and like your everyday like efforts and improving the security of your products. Few of my coworkers who like actually like contributed code, John and Graziano, many thanks to them, and lots of support from various people at Cruise. And I had like various interesting discussions over time with like various people. So we have a little blog post also about this. We describe all of the features and why and how we deploy this tool. The open source release includes like example files, also like an end-to-end like analysis tool for like Android firmware based on this. That's it. Thank you for your time. If you have any questions, I think we have like 5 minutes left. Happy to answer anything.